Hello, my name's Gabe. For this problem, we're asked to use vectors to find the interior angles of the triangle with vertices 1, 2, 3, 4, and 2, 5. Let's begin by noting that we know that the cosine of any angle theta is going to be equal to the dot product of the vectors u and v divided by the magnitude of the vector u times the magnitude of the vector v. We're going to use this formula to find the angles of our triangle. Let's first begin by turning the sides of our triangles into vectors. Let's consider first the side PQ. To write this side as a vector, it's going to be equal to 3 minus 1, which is 2, and 4 minus 2, which is also 2. So our vector PQ is a vector 2, 2. Let's also find the magnitude of our vector PQ. So recall, the magnitude of our vector PQ is going to be the square root of 2 squared plus 2 squared, which is the square root of 4 plus 4, or the square root of 8, which will simplify down to 2 times the square root of 2. Next, let's consider the side QR. Representing this as a vector, it's going to be 2 minus 3, which is negative 1, and 5 minus 4, which is 1. Let's next find the magnitude of the vector QR, which is going to be equal to the square root of negative 1 squared plus 1 squared, which is the square root of 2. And finally, let's find the vector PR. This vector will be 2 minus 1, which is 1, and 5 minus 2, which is 3. And the magnitude of PR is the square root of 1 squared plus 3 squared, which is the square root of 1 plus 9, or the square root of 10. Now we'll want to begin finding our angles using this formula. Let's first begin by finding the angle between PQ and PR. I'll call this angle alpha. So we know that cosine of alpha is equal to the dot product of the vector PQ with the vector PR. And this is all divided by the magnitude of PQ times the magnitude of PR. Now to find the dot product of PQ and PR, well, it's going to be 2 times 1, which is 2, plus 2 times 3, which is 6. So PQ dot PR is 2 plus 6, or 8. And we're dividing this by the magnitude of PQ, which is 2 times the square root of 2, times the square root of 10. Which ends up being 2 divided by the square root of 5. And here, we can use the inverse trigonometric properties to find alpha, as alpha is equal to arc cosine of 2 divided by the square root of 5 And we find that alpha is approximately 26.57 degrees. Next, we'll find the angle between PQ and QR. From the formula, we know that cosine of this angle, I'll call it beta, is equal to the dot product of PQ with QR divided by the magnitude of PQ times the magnitude of QR. Well, here, if we're looking for the dot product of PQ and QR, it's going to be 2 times -1, which is -2, plus 2 times 1, which is 2. So the dot product is -2 plus 2, or 0. And it doesn't matter what the magnitude of PQ and QR are, as the right-hand side of this equation will be 0. So now solving for beta, using the inverse trigonometric properties, we have beta is equal to 90 degrees. And finally, to find the last angle, which I'll call gamma, since we know 2 of the angles of our triangle, our last angle gamma will be equal to 180 degrees minus 90 degrees minus 26.57 degrees. Which is equal to 63.43 degrees. Thank you.